So we're going to look at where we get our petroleum products from, our diesel fuel. So it comes from crude. It's basically formed over millions of years from decomposing vegetation and animal matter, and it's pumped out of the ground, and we know it as a compound known as hydrocarbon. So essentially it consists of different numbers of hydrogen atoms and carbon atoms, okay, in different branch molecules, and different crude gives slightly different fuel depending on where it's located, where it comes from. So they take the crude oil and then they refine it. It goes into a fracking tower or column where they increase heat. They have this full of fuel of crude oil, and basically the lighter fractions are taken off as gases. So we get our LPG, liquid petroleum gas, off at the top, some lighter gas chemicals, and then we get petrol and kerosene. We get our diesel oil, which is often known as distillate, and we can have heavier grades of diesel oil. Another one is marine diesel oil, MDO, MGO. So we can get different grades of diesel, but high-speed diesels, which is mostly what we're concerned with, use distillate, the same as we use in trucks. And then we can get fractions off for our lube oil, and this is often what we call residual fuel oil or black fuel, which ships and power plants can run on. And at the bottom we get our residues, which is our tar and bitumen. Okay, so our diesel fuel is, as we said, it's petroleum based. It uses the middle distillates. It's heavier than petrol but lighter than lube oil. And here's some of these diesel grades that I mentioned: marine gas oil, diesel oil, intermediate. So as I said, we're going to concentrate on distillate. It's important at this stage to understand the process of flashpoint. You would have all done firefighting, so we need to know what that is. It's the point at which a substance gives off a vapor which will ignite if exposed to an ignition source. So flashpoint is determined like this. We take a beaker, add a small amount of fuel in it, and then we apply a flame. We put, or heat source I should say, to the bottom of the beaker, and then we take a thermometer and we supply an ignition source. And so basically flashpoint is the temperature at which it gives off enough vapor for this flash to cause a momentary ignition, and then the flame will collapse again. So it's a particular temperature, normally given in degrees C, and there's a magic number in the maritime industry that if we have a flash point above or below, it's considered to be volatile or more safe. And this number is 60 degrees C. So you need to remember that. So a fuel with a flash point less than 60 degrees is considered volatile. If it's 60 degrees or over, then it's considered to be more safe to be able to use as a source of fuel. So this table, we have some products here, and we have their flash point in degrees Celsius. A diesel has a flash point above our magic number of 60, it's 62 degrees Celsius flash point, and petrol has a very low flash point of less than minus 40 degrees Celsius. Hence, for commercial vessels, I think over about 7 meters, we are not able to use petrol as a source of fuel for our propulsion, we're left with diesel as a fuel source. We can use petrol to power things like tenders and rescue boats and stuff like that. You've got auto ignition temperature. So this is the temperature at which, if we heat the product and don't admit a flame, it will burst into flame at a particular temperature, and regardless, without any ignition source. So you'll notice that, ironically, that diesel has a higher auto ignition temperature than petrol does. And then we've got these two, LEL and UEL, so the lower explosive limit and upper explosive limit. And basically these are the ranges of air to fuel ratio at which will support combustion and which will not. So we have a range of, with diesel and petrol, they're around the same, 1 to 7% of fuel in air. So we're talking about, if we sort of take somewhere in the middle, if we have 4% fuel, diesel fuel, and 96% air, then we will be able to support combustion. If we have greater than 7%, 7.5% fuel in the air, then it'll be too rich. We'll have too much fuel, not enough air, and same if we have less than 0.6%, then there's not enough fuel to support combustion. And this is what it looks like as a sort of a diagram. So we've got flammable liquid here, and it's just showing the three states. In the middle we've got the right amount of air and fuel to support combustion. It's in the explosive range. And then we've got the upper explosive limit. Above this we haven't got enough fuel to support combustion and too much air. And we have the lower explosive limit, and under this ratio there's too much fuel and not enough air, and it won't support combustion. Alright, basically we've got three different types of fuel tanks. We can have ones that are in the bottom of the structure of the vessel, and these are called a double bottom tank. I guess because if you consider this the bottom, and this is what we call the tank top on a double bottom tank. So that's a bottom and that's another bottom. I guess that's why they call it the double bottom. Then we can have wing tanks or side tanks. So I'll just draw it again without the double bottom, because they can, but essentially it's basically part of the hull forms part of the tank as well. Or we can, so wing tanks, or we can have a freestanding tank which doesn't use any part of the hull as the structure of the tank, and obviously we're going to have framing and supports for it, but essentially the tank doesn't use any part of the hull. That's a freestanding tank. So let's have a look at the fittings and fixtures we have on a tank. This is a freestanding tank, but it's the same whether it's a double bottom or a wing tank. So, and we'll just go through each of these. So we've got, in the middle we've got baffles. So with lightning holes, we want to allow movement of fuel, but we want to reduce free surface effect. So we've also got to have lightning holes in our baffles at the bottom. Alright, we've got to have a manhole or a hand hole. We've got to be able to get into the tank to clean it out. If it's a large tank, we've got to be able to get a person in there. If it's a small tank, then we can just be big enough to get our hand in and clean that out. We've got to have a filler pipe with a valve, okay, filled from up on the deck. We've also got to have a breather. So this is showing the upper deck, or uppermost continuous deck, or deck head. And here we have to have some way for the tank to breathe. So as we're filling the tank, it's got to displace the air that's in there. And as the tank's being emptied, as we're using fuel, it's got to allow air into the tank to fill that space, so we don't have it suck under a vacuum. So on our breather, we're going to have a flame trap, which is basically a gauze which will impinge the flow of flame. If we get any of these vapors ignite, then it won't propagate back through to the tank. We're going to have a look at some other breathers as well. Sometimes we've got a type of valve arrangement to prevent water getting in through here as well. We've got to have some way of measuring the level of fuel in the tank, and there's a few different ways. We're going to have a look at some of those. This one's showing a sounding pipe. A sounding pipe has a striker plate in the bottom, so we can use a dip rod or a tape to measure the level in the bottom, and we'll look a bit more at that. A lot of our tanks have an overflow which goes back to another tank that has an alarm on it, so that if we do overfill this tank, rather than coming and overflowing out the breather, it'll go back down to another tank, the overflow tank. Our supply to our engines need to have a valve with a quick closing valve, so we need to be able to operate that valve from outside the engine room space, and with a remote, normally a cable pull system. And we've got a sludge valve here at the bottom of the tank, so we can drain off water and sludge accumulation. This one has a save all, which is like a bunding around our tank to collect any spill, and it's also got a dump valve as well if we need to drain that tank. Okay, we're just going to sketch up a fuel system. We're going to be covering fuel systems in a bit more detail during diesel engines, but we want to get the complete system, sort of basics, I guess. So here I've got two tanks, port and starboard fuel tank, breather on it, and then we've got a outlet valve, supply valve, and these are remote quick closing valve, and we go from there, join up through. This is the schematic symbol for a filter, so that's our primary filter. Lift pump, a secondary filter, and then we go to an injection pump, and I'll just draw a couple of injectors in there. Okay, so as I said, primary filter, lift pump, secondary filter, shitting me. So you need to be able to sketch up a fuel system. We're going to have a look at fuel in more detail with diesel engines, but so if you're familiar with system on your vessel, that's great. I'm just going to draw up a couple of systems that are fairly generic, which you may be able to use. So here I'm drawing a port and starboard fuel tank, and we've got a breather and our supply valve, which is a remote quick closing valve. Why do we have these? It's in the event of a fire, if we need to fire in the engine room, we want to isolate the fuel tanks. We can do that remotely with a pull system that's outside of the engine room space. Okay, so from there we go to our primary fuel filter. A lift pump. Now, a lift pump is a small pump normally driven off the engine, which is our secondary filter, and this supplies our injection pump. Our injection pump is high pressure pump, which delivers injection pressure so that we can get finely atomized fuel. Like I said, we'll cover that in more detail with diesel engines. I'm just looking at trying to put together our basic system. Here's our high pressure fuel lines, our injectors, and we always supply more fuel than is needed with our injection pump. And so here is my return, and my return is going to come back to both of my tanks, and some vessels will have a return isolation valve on those, but it's not necessary. This is a fuel system similar to what Bluefin has, and I'll show you a video in a little while. And this uses a day tank or a daily service tank, and basically it's a smaller tank that basically has a day's amount of fuel to operate the vessel with. So here would be our port and starboard supply tanks. Here's our daily service tank, DS tank, and we still have breathers on our tanks, and supply valves, which are remote quick closing valves, of course, and we still go through a primary filter, but instead of we have a transfer pump. Primary filter, and this, the engineer will start and stop the transfer pump to fill up our daily service tank level, and from there we have a supply valve here, which is also a remote quick closing valve. It's outside the engine room, and from there we go to a secondary filter, and then our injection pump, to our high pressure injection lines, our fuel injectors, and then we have a return which goes up to our daily service tank. So you need to be familiar with a system, or be able to sketch a system for orals and for our AMC exams. We've got two bunker tanks, our port and starboard fuel oil tank or fuel oil bunker tank, our fuel oil storage tanks, and they're both double bottom tanks, so they form part of the hull. They're not a freestanding tank, and we have a remote quick closing valve for our starboard bunker tank right here. So this one valve allows for it's our filling point, and it's also our discharge point, or our suction point really, for our transfer pump. So it's a remote quick closing valve, and we'll activate this in a moment. We'll have a look at how we can close that remotely from on deck, and how we set that up and reset that valve. And we've also got a day tank as well. So from our bunker tanks we use a purifier, and we purify to our day tank. The day tank is basically a smaller tank which gives us 1 day's worth of runnings.
generally. So we'll have a look at our purifier and our day tank in more detail. Our diesel oil purifier here, and with our purifier we're able to take suction from our bunker tanks, put it through our centrifuge or our purifier. This will rotate at high speed, remove any water contamination and any particle contamination, and it will be pumped from here up to our day tank as nice clean fuel. From our fuel oil purifier we come up through here, through that valve, and up into our day tank discharge valve. So that's one method we can fill our day tank from our fuel oil purifier. We also have a fuel oil transfer pump. So from the same bunker tanks we can also open the right valves to pump up from the bunker tanks through this valve using our transfer pump, and opening this valve will come in and fill this tank as well. This doesn't have a sight glass. This has got our remote sounding pipe as well, and we'll take a look at, we've also got another level recording device called a pneumacator. We'll have a closer look at that. We can, if all else fails, if we end up running out of fuel and we lose all suction and we're black out, we can't start an engine because we don't have fuel in the day tank, then survey requirements are that we've got to be able to pump it manually by hand. So in that instance we've also got a hand pump which we can pump. It's the same suction line from our bunker tanks, but it's using a semi-rotary hand pump that we can then use to pump up our day tank and then get a start on one of our engines. As well as having our sounding pipes on deck, we've also got what we call a pneumacator. So it's, the prefix of that is pneuma or pneumatics. It uses the pressure that the volume of liquid in the tank is exerting, and it's calibrated so that we get a corresponding tank level measurement on this gauge. So this one gauge can be used to measure all of the tanks that we've got. In this instance we've got 3 tanks on board. So what we have to do is we come to this valve setup here, we select which tank we want to read, whether it's the port or starboard bunker tank or our day tank, and then we've got this device which helps us calibrate the level that's in there for the tank that we want to read. And it's a 4-part process. We start with the zeroing and we wait a period. What it's got to do is use pneumatic air pressure to push all of the fuel in the line back to the tank, and then we wait, we zero it, we go to a purge cycle, and what that's doing is now allowing the fuel to come in and work against the air pressure that we've just applied to it. We go to another position called wait, give it 10 seconds and it just lets the system calibrate, and then we can go to the read part of the cycle, which I'll switch over now, and we should see our level come up, and this is going to correspond to the level that's in the tank that we're reading. We're looking at our day tank low level alarm. So that's a float switch. So if our tank level drops below that point, then it's going to set off an alarm that it's time for the engineer to pump up the tank. We've also got a high level float switch, and that's up in this corner here, and similarly or conversely, if we overfill the tank or we forget to shut off the transfer pump or the purifier, then it's going to give us an alarm to read that our tank is nearing its top of the tank. We've also got an overflow, so that if it does get beyond the high level point, then fuel oil will flow through and gravity drop down that pipe and go into our portside bunker tank. The discharge to our engines, that's our generators and our main engine, is also through a remote quick closing valve, and this one then goes through our primary filters, then to our secondary filters on our engine, and we'll activate the remote quick closing valve so that we can see that in operation. I've just put the cantilever in the right location so that as soon as this cable's pulled, the valve will pull across and drop and instantly close. So I just open it all the way, back it off a slight bit. Here we've got the remote fuel shut-off valves. These are for the two bunker tanks, our port and starboard fuel double bottom tanks, and it's simply a matter of once they're open and set, and when I pull the lever, that's going to operate it downstairs and close the valve. We've also got one down here for the day tank, which is back down under here on the deck. This just has a simple cable pull system, and when I pull it, it releases through that cable and will close that valve. If there's a fire on board, we can isolate our fuel from being a further fire risk.
So here's several types of breathers. As we said, a way for us to ventilate the tank, air in or out, and they have a flame gauze or a flame trap, and this is basically it's a gauze that reduces the flame impingement, so if vapors are ignited it's not going to go back down into the tank. Some of them, this one is a breather as well, and it's got a flame gauze on this little gooseneck here, but this one also has a ball which is a float, so that because this is on the main deck, it's got to be on main deck or higher for our breather, and if seawater came in through here, then there's a ball that would float and prevent any seawater getting back down through into the tank. Our remote quick closing valves, this is one similar to you just saw on the Bluefin video. So these ones, when they're in the open position, it winds up against this spring pressure, and if the this lever is pulled through a wire onto the upper deck or above, then it will instantly close that valve. But it can be as simple as a ball valve, which will just have a wire pull which pulls 90 degrees to close. Here's some different types of couplings that we might have to refuel our vessel. This is probably the most common. This is a cam lock coupling, and so they're in a male and female part, and this is the male end, this is the female, and when they come together and these locks are brought down, then it provides a good seal. It's actually an O-ring seal, a square O-ring on the inside of this, which causes it to seal, and the cam lock, like the snail shell, it's as it pushes down, it activates in this recess here to lock that two couplings together. This is, on larger vessels, they tend to use flanged couplings, where we bolt a hose on with a flange straight onto a flange for the inlet with a valve normally beneath that. These are used on some vessels as well. This is called a dry brake coupling. Now these have a spring-loaded valve on either side, and it's only when the two components, the male and the female, come together that it pushes against each other and opens the valves against the spring pressure. This one's also got a valve. So the idea of the dry brake coupling is that if the coupling does separate, it's got valves on both sides, so we shouldn't get any leakage. Alright, some different ways of determining level in our tanks. So we have a basic sight glass, and this one is a fully sealed glass, which basically we've got two open ends that go into the tank, and our level is recorded in the, according to the level that's in the tank. Or we can have float switches, which give a level indication, and So we call this is a type of transducer. It's giving an electrical signal according to the level on that float. These are more often used as alarm points. So when it hits a certain point, then we trigger an alarm for a high or a low level alarm, but they can be used to also indicate level as well. Magnetic level indicators. So these have a column that allows fuel to flow, which is in behind these little flip indicators. Yeah, so it's a column that is open to the tank at top and bottom, and there's a little float that rises up and down inside of that, and it has its ferrous, it's got metal in there, and this corresponds to these small little magnetic little pieces which can flip 90 degrees, and as the float rises it causes these to flip over and indicate red, and as the float lowers, then they flip over the other way and turn white. So that level in between the red and the white is the level in the fuel tank. We can also use pressure as an indicator of our level in our tank, and this one has a pressure transducer, and it's giving a signal according to the level that's in the tank. These days they tend to have a pressure transducer in the bottom of the tank, and because head pressure, the higher the level in the tank, the more pressure there is at the bottom. And so if we can take a pressure transducer and we can calibrate the pressure that there is at each of the level in the tank, we can put that through to a level indicator. And then lastly, there's the Pneumicator. That's the one you saw on the Bluefin. It's a pretty old school sort of system now, but basically it's relying on the level that's in the tank, exerting pressure on this pipe, and once we line up the right valves, this will give an indicator with a scale that's calibrated according to the pressure that's exerted by the fuel on this pipe work. It's important that we have a procedure for refueling, basically a checklist of things we're looking at for a refueling procedure. So we're going to have a bit of a look at all the things that we might possibly want to think about and consider for refueling, but then we want to condense that list so that we've got a concise but not too cumbersome list that we can sort of rattle off in orals or for examination purposes. So yeah, this slide gives us a lot of information here. We're just going to run through each of those, and from that we're going to narrow down and pinpoint what are the essentials that we're going to need for our refueling procedure. So we've got comply with port regulations, ensure personnel involved understand the system, notify all personnel on board, no welding naked lights, check the vessel securely moored, no smoking signs, B flag, the Bravo flag, red flag or one red light at night. Keep fighting appliances in readiness. It's got a foam AFFF foam extinguisher, a spill kit, plug the scuppers on decks. We'll talk a bit more about those. Ensure correct valves are open and fuel tanks are open, vents are clear. We've got save oils or a spill tray below our fill point. We'll talk about that. Our fuel lines secured to prevent moving or chafing. Ensure the refueling hose is bonded to the vessel. We'll talk about that. Refueling lines should be long enough to allow for interaction or movement from the vessel or from passing vessels. Smooth bends, no sharp edges. Cam lock connections wired. Fuel line is earthed. We'll talk a bit more about that. Sound the tanks, check quantity, check fuel type from supply. If it's from a road tanker, agree on flow rate pressure. Positive communication with person operating the fuel pump. Ensuring the incoming fuel is clean. pipe joint shouldn't leak, maintain a constant watch, refueling points to be manned. On completion of refueling, hoses to be blown through with air, shut off all valves on completion. Alright, so just going to pick up on a few of these things and we'll talk in a bit more detail, then we'll come up with our concise list. Just going to run through some of the terminology that we've discussed. The first term is scuppers, and in case you haven't heard that term before, it's basically where we have our vessel. It's anywhere that the water is allowed to run off the deck, whether it's rainwater or seawater, but it can be the natural camber of the deck, where water can spill off. But a scupper is essentially the drain that allows the water to drain off. So it can be, we might have a tow rail or a bulwark, and it can be simply a plug or a drain in the deck itself, which allows the water accumulation to drain off. The tow rail itself, if I draw it in this perspective, can have little lumber holes in to allow the drainage of water off the deck. So there's many different ways to achieve this, but if we consider that with the generic term scuppers, the other one is, another term it mentioned was an earthed or bonded fuel line. So in aircraft refueling, anytime we have liquid flow through a pipe, then we can build up static electricity. And in the aircraft industry, what they do is they, from that line, they bond it down to earth to diffuse any of that static electricity and reduce any chance of spark causing ignition of the fuel. And this one's mentioned, but I've refueled a lot of vessels and I've never had to use an earthing strap yet. Okay, so what we're going to come up with is our concise textbook answer for refueling procedure. So understand and comply with all port regulations. See, to me that's, stated. So I'm going to axe that one. Ensure all personnel involved with the operation understand systems and procedures. Yeah, look, we would definitely do that. Make sure everyone knows what they're doing, but I'm not going to include it in our concise list. Notify personnel on board. Yeah, I'm tempted, but I don't think so. I'll highlight that one anyway. We might come back to it. Check the vessel securely moored. Yeah, I think that one's good. No smoking signs, definitely. Put up the B flag or one red light at night. That's important. Keep firefighting appliances in readiness. Yeah, we would use portable foam. It's the best for our B class fire. Yes, we want to have a spill kit there ready. We want to plug scuppers on deck, definitely. Check that correct valves and fuel tanks are open. Yes, we definitely do that, but we're not going to include it in our list. Yeah, vents, we tend to call them breathers, not vents. Yeah, we're going to check our breathers and make sure that they are free, but I'm not going to include it in our list. Save all below the fill point. Yeah, but we're trying to make it concise. We're going to take it off. Fuel lines should be secured. That one's just obvious. We do need to do that. Bonding the fuel hose. No. Long enough fuel lines. Yeah, no. Pipe bends are smooth. Not over sharp edges. Correct, but not on our concise list. Alright, we do want to wire the cam locks closed to prevent accidental release of the coupling, but no, we're not going to include it. We're not going to include earthing. We are going to sound the tanks and check quantity, but we're not going to include it on the list. Check the fuel type from the shore supply. Yeah, we need to make sure we get a bunker note from the supplier. Make sure we got the right fuel. low sulfur diesel. Alright, we want to agree on the flow rate pressure, that's true. But the main thing we want to know is that we have positive communication with the person operating. So we want to have someone on standby who's in communication with the supplier, whether it's a truck or whatever, or straight from a Bowser. But our positive communication, normally on a small vessel, it's verbal. So we're normally within line of sight with each other. We can yell out, and if we need someone to stop. We need to sample the fuel. Look, it depends. Normally with our high grade diesel fuel, it's not so much of an issue, but look, it is a good idea to take a sample and retain it on board. We just get a clean sample container and take a sample of the fuel that's coming in, and if there's any argument or contamination, we've got something that can be analysed. Pipe joints should not leak, that's true. Maintain a constant watch, that's true. So if we're using our standby person, we want them to be a competent person that's not going to disappear just because they get a phone call or a text. The refueling point is to be manned at all times, that's true. They can't walk off the job. On completion of refueling, that's on larger vessels, we blow through with air. And shutting all valves on completion, we do that. But alright, so now we're going to write it up as our concise lists so that we can come to a point. Incidentally, another word for refueling is bunkering. You may have heard that term before. Bunkering or refueling. Okay, so let's go through our checklist of the textbook answer, things we need to be able to say in orals or exams. Alright, so the first one is notify the port authority. Now I know it depends on which port you're in. Secure the vessel. Allow for surge, tide, all that sort of stuff. No smoking sign. The supplier should have that, bring that with them to put on the wharf. We want to have a fire extinguisher. As we said, for a potential B-class fire, the best is foam. Which colour is foam extinguisher? It is blue. Okay, we want to have our spill kit ready. We want to plug the scuppers. This can be bunding, we can use rags, we can use those oil absorbent pads or sausages. And on a lot of ships, what they do, they plug the scuppers with rags and then put cement over the top of them. Anyway, a few different ways of doing that, but we want to, if there is fuel onto the deck, we want to be able to contain it on the deck and not have it run into the water. We want to establish communications with the supplier, and as I said, this can be straight verbal communication through line of sight, and then we want to have a standby person who is at the supply point and that knows what they're doing. Alright, so there we have 2, 4, 6, 8 points. So we've narrowed that right down to what is the concise kind of key points that we would need to know, and we should know, particularly for orals. Now, I've got a question for you. Who is in charge of refueling? Alright, if we are the vessel and we're taking receipt, who gets to control whether it's when we start and stop and what flow rate? Okay, it is us. Alright, we're in control of the refueling procedure, and don't be pressured by a supplier just who's keen to get on with it and get the job finished. Okay, the last thing we want to do is to have a spill, and to try and prevent that, then particularly as we are getting high in our tank level, we want to slow that rate down, because it can come up on us very quickly and we can very easily have an overflow. The other point is too that we don't want to fill our tanks all the way to the top, Okay, we're entering into a danger zone here. So a really good policy is to fill our tanks to about 85% capacity. We're going to be doing a lot in the pracs on how we measure the tank volumes, particularly with larger vessels that we're dealing with. We'll be doing a prac on bluefin where we've got to do soundings and use tank tables to determine what level there is in the tank and where we need to stop.
Okay, so our refueling hose comes from our delivery truck, our refueling truck, and as you can see there's no sharp bends, we're not going over anything sharp, no pinch points, and then our refueling hose will come and attach at our refueling point or bunker point. We'll take a closer look at that. So this is positioned in a bunted area or with a catchment, a save all, and this goes onto our refueling point. This one uses Camlock couplings, and it's been locked with mousing wire so that they can't inadvertently open through vibration or any other means. And we have our refueling valve, and then we can put it into either of the bunker tanks depending on which valves we open downstairs. We had a look at our fill point from our bunker station, and you can see it's this one right behind me, and this is dropping straight down from our portside fill point and drops down here. There's a similar one on the starboard side. They both meet up and go into our bunker suction valves. So the one valve, our quick closing valve, is the fill point and the suction point for our transfer as well. We've got to have a way of measuring the level in the tanks, and in this instance we've got sounding pipes, and we've got one for our port and starboard bunker tanks, and they've got caps on top of the sounding pipe, and these go all the way through to the bottom of the tank, and we've got a striker plate at the bottom which is like a doubler plate, so that when we actually sound and we hit it with the bottom of the weight, it won't just keep punching and eventually punch through the bottom of the tank. So that's the purpose of the striker plate. And the procedure with using a sounding tape, we just simply lower the weighted tape down to the bottom of the tank until we feel it hit bottom. Okay, so I can feel it hit bottom now, and then what I do is I stand back, and what I'm looking for is the liquid that's on the diesel fuel that's on the tape. So I get into a place where I can see reflection from the light, and I'll just keep winding until I see the level. With a bit of practice you get quite good at reading what the level is. So it's getting really shiny around this vicinity, and I can see just in the light where my level is right here. So I've got 1.20 metres. So that's the level right now. Once I've established that, I'll note that and we can work out what the volume is. But it's important at this stage that I have a handy rag, and what I'm going to do is wipe a section of tape. I'm going to reel it in and then wipe the next section of tape, wipe the weight, because what happens is if I wind it and I've still got diesel fuel on it, it's going to wind up into the tape, the whole thing will get wet and it'll be impossible to read. I'll have to string it all out and wipe it nice and dry. So that's the procedure. We'll work out from there the level that's on the tape. We can work out how much quantity of fuel that we have in the tank itself. So we just got a collection of oil absorbent pads. They'll soak up oil but not water. And then we've got an array of sausages which we can use to bunt, and which you can see displayed down here around the refueling hose, around the scuppers. And then right beside us here we've got our foam fire extinguisher on the ready, and we're set up for bunkering. We also have a larger spill kit which is located on the upper deck here, and that contains the smaller spill kit which we've got downstairs, plus a vast array of different oil absorbent pads as well. Often has some kitty litter in it as well, which is oil absorbent material that we can throw down on the deck if we get a spill. So our two main bunker tanks, they have to have our breathers to allow air in when the tank is emptying, and then it needs to dispel air when we're filling. So right now, while we're refueling, air is being pushed out of the tank. Now that serves as a pretty, it's a fairly dangerous time in and around this vicinity, because it's pushing fuel vapours out of the breather. And so we want to, obviously in our bunkering procedure, we're making sure there's no hot work occurring at that time. But the air vent itself has a gauze just inside here, and that's a flame trap, so that for whatever reason, if any vapours are ignited, then it won't be able to travel past the flame gauze and down into the tank and cause an explosion. So it has that flame gauze to arrest any fire from going in. We also have another feature of this breather, and that is we need to allow air to pass in and out depending on the state of the tank, but we want to prevent seawater from getting in also. So to prevent that, we've got a downward facing shield, but we've also got a ball that acts as a float in here. So if any water does get in for whatever reason, it floats the ball and stops the seal and won't allow any water or liquid to travel into the tank. Also, we looked at our sounding pipe which we had downstairs for our two bunker tanks. We've also got another sounding pipe which is on the upper deck, which we can also use to sound those tanks as well.
If you're involved in an oil spill, whether it's from refueling or from transferring fuel, then we need to stop immediately the refueling or the transfer. We want to try and relieve the pressure on the fuel tank to another tank. So we can open up another tank valve just to take that pressure off, because it will tend to keep spilling for quite some time when it's under pressure. Okay, we want to muster and get all hands on deck, apply our spill kits, and look, if the spill is in the water, then the first thing we want to do is notify the Port Authority. Now, this is mandatory, okay? We must do this, because if you fail to notify and it's found out and proved that it's from your vessel, which they can do, it's like forensics, they can tell exactly where a fuel's come from, then you're going to get in serious trouble. Okay, the other thing is, if it's in the water, we don't apply dispersants or detergent. Okay, this might mask the and trying to disperse the oil slick, but it causes other problems. So unless you're asked to administer dispersants, don't do it. All right, and then it's a matter of using rags or kitty litter if it's on deck, oil absorbent material to clean up the spill, and the oil absorbent pads. These are great. You can even put them in the water if there is a spill in the water, because they absorb oil and not water. That's the way they're designed. Oil records, we've mentioned briefly before, they're an AMSA document for vessels within Australia, and they basically require you to enter whenever you transfer fuel or sludge or refuel the vessel, and you just have to put in the date, the time when you start and finish, vessel's position at start and finish, or if you're alongside, where you are alongside, quantity, how much you've taken or discharged, and then signed. So liquid petroleum gas, or LPG, it's a gas that comes from the refining process that we discussed as a lighter fraction of carbons and hydrogen, and it's basically often a mix of propane and butane, which are different products of carbon and hydrogen. And it's stored under pressure as a liquid in a cylinder, and generally inside our cylinder is around 8 to 9 bar. Then we have an isolation valve and a hose to, in this instance, a pressure gauge, and then we've got a regulator. Now, a regulator is to reduce the pressure from our cylinder pressure to our operating pressure that we need for our appliances, namely a cooker and the galley. And generally our appliances require about 2 to 3 bar from our regulator. From here we're going to a solenoid, which is just an isolation valve that has a switch in the galley, so that after we've finished using the cooker, then it can be isolated safely from the galley. All right, from here it goes to our cooker or various appliances in the galley or elsewhere. Okay, our liquid petroleum gas, when it's released as a gas, if we have leaks, it's a heavier than air gas, so it will sink. So here's a picture of a regulator here, and just remember with LPG we've got an O-ring seal on here, and these are left-handed threads. So for our fuels with flash points below 60 degrees Celsius, which is our petrol and our LPG, then we need to install tanks and bottles securely and as far as possible from any heat sources, so engine and exhaust pipes. Our compartments should be well ventilated, so if it's in a compartment, then we need to have ventilation at the top and the bottom, okay, particularly for LPG. And then provision for external inspection of tanks and fittings. So we need to be able to access it to do inspections. LPG gas cylinders, their high pressure stage and regulating equipment shall be secured in a position on the open deck. Okay, so we can't have it inside the accommodation, outside of enclosures, and at least 1 metre measured horizontally from any opening leading below decks. So any opening into the accommodation from the main deck, our cylinder needs to be installed at least 1 metre away from it. Protected from climatic extremes, okay, we don't want to have it on an open weather deck, and if it's housed, then we need venting at the top and bottom, obviously, so we can get airflow through it, and because it's a heavier than air gas. These are getting much cheaper on the market. This is just a electronic sniffer which can detect the presence of LPG gas.